This lesson is on applications using distance and midpoint. We're going to start with the distance formula. Now this formula is on your formula sheet that is available to you on every test, including the state exam, the EOC. The hardest part of this is actually just typing it into the calculator properly. So we will practice doing that in class. But you're going to start, and I'll move over to my Desmos screen in a moment. You're going to start by just typing the formula in, because once you do it right once and leave it at the top, you can always copy and paste it and replace the letters with the numbers. So we're going to look at finding the distance between 2 points, and you'll be given the points. Each point has an x and a y. We're going to call the first ordered pair x sub 1 and y sub 1, and the second ordered pair x sub 2 and y sub 2. Those subscripts only help us tell the difference between whether we're looking at the first ordered pair or the second ordered pair. They don't do anything mathematically to these numbers. They're just a way of telling the difference between the first pair or the second pair. But you can see the formula contains these subscripts also, and so we'll be able to plug everything in just where it belongs. Give me a moment and I'll put Desmos up for us. All right, you can see that I've already typed the distance formula into my first field. It's really important to get that right. You have the square root over the whole thing. You have to have your subscript numbers. They're easy to put in Desmos. If you type X and then the number 2, Desmos is so smart that it knows that you wouldn't be putting a number after a letter unless it was meant to be a subscript, and it'll make it that way for you. And then when you square something, the parentheses are each squared, you use this A squared key on your keyboard. The on-screen keyboard is the best place to do this. Okay? So copy the formula carefully and put it in once. I also put the points that I wanted in, so we have a visual. What we're looking for is the distance between those 2 points. Now, it would be really nice if both of the points were on the same line on the grid, on the graph. That way we could just count. But we can't. So we're going to use this formula instead. The nice thing about Desmos is it lets you highlight, copy, and paste this formula. Now, I told you on the last slide that we want to just plug those numbers into the right spots. And so we'll remind ourselves here, this was x sub 1, this was y sub 1. This was x sub 2, and this was y sub 2. And now you are literally going to highlight your x sub 2 and replace it with -4, because that's what we decided x sub 2 was. And x sub 1 is here, and I'm going to replace it with the 3 because we labeled the 3 as x sub 1. Y sub 2 is 13, so I'll make sure I highlight it and type 13. And y sub 1 is -17. And since there's a minus there, I'm going to use an extra set of parentheses around that -17. Oh. Now I know you have to be really careful in doing this, but when you're done, it gives you the distance between the 2 points. This is it. They might tell you what the units are, inches or feet or centimeters or whatever. They might tell you to round to 1 decimal place, in which case you would say 30.8. But whatever it is, if you're careful about entering the information, and remember, this formula will be given to you, then it's really easy to get the answer. You just have to pay really close attention to the details. All right, it's your turn. I want you to try one. Label your point. By the way, doesn't matter if we call these the first one and these the second one, or if we switched it around. Out of habit, you're probably going to call your first ordered pair x sub 1, y sub 1, and your second ordered pair x sub 2, y sub 2. But either way, it's going to work as long as you don't mix up your ones and your twos. Go ahead and try this one now and then come back and check your work. So, how'd you do? I hope that you didn't waste time rewriting this formula again. Copy the formula, paste it in a new field down here. I put in my points so that they're in front of me every time, but if you have them written on your paper and just label x sub 1, y sub 1, x sub 2, y sub 2, that's fine as well. And then just highlight and replace each piece of the formula with the number that you labeled. In the end, you get the correct answer every time as long as you're careful. So how and why do we need to use the distance formula? Anytime you need the length of something on a coordinate plane, on a graph, you're going to use the distance formula to find length. Length is the distance between the two endpoints. In this case, we have a right triangle. Here's the right angle. Here's the hypotenuse. They give us A, B, and C, the corners of the triangle, and they tell us to find the area. Okay? The formula for the area of a triangle is 1/2 times base times height. You need the length of AC and the length of AB. And then you can plug those in. So let's take a minute and use the distance formula to find the length of AC and then the length of AB. So to start, I put my ordered pairs into Desmos so they were in front of me. Again, if you have that on paper and you're labeling your X1s and your Y1s and your X2s and your Y2s, that's fine also. I copied my formula, I pasted it down here, and then I highlighted and retyped what X2 was, what X1 was, what Y2 was, what Y1 was. I plugged all the numbers in for A, B, and I got approximately 6.3. So now I'm going to do the same thing for A and C. And so you're going to call, let's say A we'll keep as our X sub 1, Y sub 1, but now we'll make our C X sub 2, Y sub 2. I'll show you what I mean. All right, I found the distance from A to C, which is my base. I plugged everything in, and when I round to 1 decimal place, I get approximately 3.2. So now I plug these numbers into my formula for area of a triangle. 1/2 times the base times the height, and I just put that in the calculator. I can use another field right here and type 1/2, move your arrow out, times 3.2 times 6.3, and I get 10.08 as my area of my triangle. This one I want you to do. Keep in mind that this is a rectangle. It's just turned on its, tilted a little bit diagonally, right? But the area of a rectangle is length times width. So you're finding the length of this side or this side, either one, they're the same, right? And then the length of the short side, either one, again, because they're the same. So once you find the length and the width, you multiply those together. We'll check your work in class, but make sure that you try this one on your own. The next thing we need to talk about is the midpoint formula. This is also a formula that's on your formula sheet, and it looks complicated, but I promise you it isn't. The midpoint is just the middle. It's like average. So if you think about it as an average, you know to find the average of two things. You add them up and you divide by however many things there are, in this case 2. So you can see that we're adding our x values from our points, in this case 8 and 7, and then we'll divide by 2. So 8 plus 7, and we'll divide by 2. And that is the first half of our midpoint ordered pair. And then we're going to average the y's. So we're going to take the -3 and the 5, add them up, and divide by 2. We're always dividing by 2. Once we do the math here, we get 15 over 2 and 2 over 2. Now that simplifies a little bit. We could write this midpoint as 7.5. You can do it in the calculator, comma, 1. And if you put this point and this point and this point, all three in Desmos, you will see that this midpoint is exactly in the center of those two other points, the middle. Okay, so you're going to find the midpoint of the line segment shown. I promise it's easy. You know that it's going to be right around there, right? Well, let's see how we can do it mathematically. First, we need the ordered pairs. So you need to be good at this. This ordered pair is -3, +3. This ordered pair, start at the origin, -1, 2. Now remember what I said. Midpoint is averaging your x's and then averaging your y's. So to average your x's, I take both my x values, I add them together, plus -1 or -1, they're both negative, over 2. And I take my y's and I add them together over 2. This gives me -4 over 2, 5 over 2. And depending how they want your answer expressed, you might rewrite this as -2, 2.5. That's it. So what if you were given one endpoint and the midpoint? Would you be able to work your way backwards to find the point? And that's a task that we're going to talk about together in class.